Question 1. Drag each tile. Not all tiles will be used. Given the Pythagorean theorem, x squared plus y squared equals r squared, where r is the distance from the origin to the point xy, place the steps in correct order to derive the Pythagorean identity cosine squared plus sine squared equals 1. Let me do that in a different color. Let's pick kind of purplish, if I can write. So our goal here is to go from what is red, circled in red, to what is underlined in purple in this problem. So you can see we've got our picture. This is ultimately where x squared plus y squared equals r squared comes from. We've got our right triangle. They're just doing the Pythagorean identity. So I'm going to start by rewriting that because that is our starting point. I'm not even going to look at the steps for now. But let's think about it. Our goal is to make this cosine squared plus sine squared equals 1. So I can kind of tell where that 1 could come from. And it might be helpful to look at the steps down there below as well. Because if you take a look at this step right here, this would immediately give us a 1 on the right-hand side of that equal sign if we divide everything by r squared. Remember, you can do anything to an equation as long as you do the same thing to all of the terms. So r squared divided by r squared is 1. We've got x squared divided by r squared. And we can rewrite that, so it's a little cleaner, as x divided by r, all of that squared, plus y divided by r, and all of that squared. And you'll notice that, so this was step 1, that right there is a step in itself. So we can kind of combine steps 1 and 2, but step 1 definitely occurred first. Now finally, let's think about what is cosine and sine. So recall from your days in geometry or from the unit circle, cosine is the adjacent side of the triangle divided by the hypotenuse. And of course, our reference angle is right here represented by theta. So the adjacent side to that angle is x, and the hypotenuse side is r. So cosine, remember, can be rewritten as x over r. It's the adjacent side over the hypotenuse. Likewise, sine is equal to the opposite side from the angle theta divided by the hypotenuse. Well, the opposite side from theta is y. So we're going to rewrite sine as y over the hypotenuse r. So you'll notice this and this are the same thing. So we can replace y divided by r with sine. Well, specifically sine of theta squared. They write that order a little bit strangely. But then we can do the same thing with cosine equals x over r. We can replace x over r with cosine squared of theta. And that is our final step, step number 3. A couple things to point out why the other steps wouldn't be used. This step right here doesn't really help us because if we divide r squared by r, we're not left with 1, which really is our ultimate goal. So that step would not help. Plus, if you have x squared divided by r, we can't simplify that to cosine because we have different exponents. And then same thing here. Notice they're subtracting r squared to the other side and equaling it to 0. We want it to equal 1 because they want that specific Pythagorean identity for this problem.